I'd like to introduce an important technique as part of solving quadratic equations, and let's look at this problem. I'm going to solve x squared equals to 25. Now you can just look at that problem and I'm sure you can immediately see that the answer is x equals 5 because 5 squared is 25. But there's another answer, isn't there? Negative 5, when you square that number, also gives you positive 25. So there really are two answers here, 5 and negative 5. Now we could get those answers methodically by factoring. So if I subtract 25 from both sides, it equals to 0. And we're able to factor the left side. This difference of squares gets split up into a product of conjugates. Remember the word conjugate from the complex number section. And this product of numbers equals to 0, so we can set each factor equal to 0 and solve. X plus 5 equals to 0, x minus 5 equals to 0. So here when I subtract 5 from both sides, I get a negative 5. Here I add 5 to both sides and I get positive 5. So there's how we could display a technique for finding both answers. But this seems to be a bit of work. And so why not take advantage of the square root? So let's remember now that you've got two answers here. I'm going to go back to the beginning, and I want to, for reasons that'll be apparent in a minute, I want to put a little space here between the equal sign and the 25. All right. I'm going to take the square root of both sides. So make each side, fit each side inside a square root symbol. Now that should be okay, right? Because we're doing the same operation to both sides of the equation. So what is the square root of x squared? It is x. And the square root of 25 is 5. So there's an immediate shortcoming to this method because it didn't give us the other answer, negative 5. Well, there's a pretty good reason for that. It's because actually the square root of x squared really is not equal to x. And not always, at least. It'd be more accurate to say that this is equal to the absolute value of x. I'll give you an example. If you took the square root of negative 6 parentheses squared. Alright, so negative 6 in parentheses is squared under the square root. Do I get negative 6? No, because negative 6 squared is positive 36, and then the square root of 36 is 6. And so, in other words, this is equal to the absolute value of negative 6, which is positive 6. Because recall that a square root is a function, and by definition its output is always a positive number, or it could be 0, but never a negative number. Alright, so this, technically speaking, the square root of x squared is actually an absolute value. And that takes care of getting a positive answer. So, but if you were to look at the absolute value of 5, I'm sorry, let me, if you looked at the absolute value of x equals to 5, then you'll see that there are two answers to this. The absolute value of 5 is 5, and the absolute value of negative 5 is also equal to 5. So it gives two answers. Well, rather than dance around all this absolute value business, our chosen way to fix this and these problems is to introduce the plus or minus symbol. So I'm going to put a plus or minus here. Now that's a plus sign with a little line underneath it. And so it represents two answers. X is equal to plus 5 or minus 5. So now we could, rewrite this as x equals -5, comma 5, represent two answers that way. So here's the kind of the summary of this. When you solve an equation by taking the square root of both sides, you actually are creating two separate answers, a positive answer and a negative answer. And to account for a positive and negative, we can accomplish that by putting a plus or minus symbol in there when we take the square root of both sides. It wouldn't matter if we put the plus or minus symbol on the left or the right, but since we're solving for x, it'd be logical to put it with the number. This, just mention this briefly, this idea of when you take the square root of both sides you get two answers is actually a general fact. If you were to solve this problem, x cubed equals to 1, by taking the cube root of both sides, you might say, well, there's only one answer. 1 to the third power is 1. So the cube root of x cubed is x is equal to the cube root of 1, which is 1. So there's our answer of 1. Well, actually, there are three answers to this problem. And so if you take a square root and you get two answers, then it may make some sense that when you take the cube root of both sides that you might get three answers. Matter of fact, let me write out the three answers. I'm not going to begin to show you how you get these, but you would study this in a trigonometry course if you take it. There's a lot of geometrical things going on here, but actually this problem has the following three answers. X is equal to 1, x is equal to minus 1 plus the I times the square root of 2, everything divided by 2, and it also equals to minus 1 minus I times the square root of 2 over 2. So you'll either have to take my word for it, or you could verify this if you take one of these two complex numbers and raise it to the third power and do all the rather nasty, complex arithmetic on it. You will get positive 1 for an answer. So, this notion of solving by using a radical sign introduces multiple answers. And but the main thing here is to learn about solving by taking the square root, the so-called square root method. All right, now let's get back down to earth, and I'll solve one or two more problems here for you by using the square root method. And it turns out this, as you'll see in the upcoming videos, this is sort of a cornerstone of our quadratic formula that we're going to develop, the square root method. So suppose we're going to solve 3x minus 1 in parentheses squared equals to 5. All right. Well, the square root method, here's when it works the best. Well, actually, it's when you can apply the square root method, is when you have some quantity squared. So some quantity squared, and I'll depict it this way, equal to a number. And by number I mean a constant number, no variables. So as long as I have all my variables on the left side, and this whole mess has been squared, and all I have on the right side is a number, just a constant, no variable, then we can take the square root of both sides and use the plus or minus sign. So let's do that up here. I'm going to eliminate this exponent of 2 by applying the square root, and then I need to fit in the plus or minus sign, because again there are always two answers when you take a square root. Then in this method, the left side, it does in fact cancel the 2, and again, by using the plus or minus, I don't have to think about the absolute value signs. We just do it this way and everything's going to be fine. So I have 3x minus 1 is what's left over on the left, On the right, it's plus or minus the square root of 5. And then I'm going to add 1 to both sides. So I have 3x equals to 1 plus or minus the square root of 5. And it's traditional, or at least conventional, to put the plus or minus square root term on the right in these expressions. Notice I can't combine these numbers because they're unlike. One is an integer, the other one is a square root of 5. They don't mix together. I can't combine them into a single term. And then divide by 3. And so x equals to 1 plus or minus the square root of 5 divided by 3. Now that means that the two answers actually are x equals to 1 plus the square root of 5 all over 3, and 1 minus the square root of 5 over 3. So there are the two answers. It's okay to me if you leave it in this form, but I do want you to recognize that there are two separate answers represented by this form here. Okay, let's do one more for this video. And it'll be a similar problem, except this time we're going to get a complex numbered answer. So let's solve 2x plus 8 is equal to quantity squared is equal to negative, I'll tell you what, let me do it this way, plus 17 equals to 0. All right, 2x plus 8 in parentheses squared plus 17 equals to 0. Well, by isolating the squared term, I'm going to subtract 17 from both sides. I end up with the form, which is great for, oops, sorry, getting ahead of myself. It's just negative 17 on the right side. We have it in the form that's ready for the square root method. So, going to, because we have variable term, which is squared, equals to a number, no variable on the right side. So I take the square root, both sides, put in the plus or minus sign to account for two possible answers. And now we have square root of a negative, so that introduces a complex number. On the left, the exponent 2 is canceled, so I have 2x plus 8. On the right, this is I times the square root of 17. So it's plus or minus I times the square root of 17. And by the way, I don't write that this way. It might seem more natural to write this by putting the square root of 17 first and followed by the I, because we typically put letters after numbers. The reason I don't do that in teaching is because I've seen a lot of people carelessly put the I under the radical sign. And that's wrong. That's a totally different number from this, because the square root of I is a number. It is a number. In fact, if you ever wonder what the square root of I is, the square root of I is equal to 1 plus I times the square root of 2 over 2. So there we go. Okay, so you don't want to mess with putting an I under a radical sign. That's why, again, just one more time to harp on this. I think it's a good idea to write I to the left of the square root, and then there's really no danger of committing this careless error. Well, let's finish up this problem, because we're still solving for x. So I'm going to subtract 8 from both sides. 2x equals to negative 8 plus or minus I times the square root of 17. And now I'm going to divide by 2. So x equals to negative 8 plus or minus I times the square root of 17. And everything is divided by 2. So that was our answer. And we could write this out as two separate answers also. But there's the idea. Okay, I think just to wrap up this video, it occurred to me as I was writing this, I made a mistake earlier in this video, and I really don't want to go back and re-record it. So let me fix a little mistake I made earlier. And it was when I was discussing the solution to this problem, x cubed equal to 1. We take the cube root of both sides. The answers are x equals to 1, and then it's going to be, let me think here, minus 1 plus I times the square root of 3 over 2, and minus 1 minus I times the square root of 3 over 2. So I think what I did earlier in the video was put square roots of 2 there instead of square roots of 3's. Anyway, this would be correct. I was a little careless doing all that trigonometry stuff in my head. Alright, not a big deal, but I do like to fix the video. Okay, well, next video we'll talk about simplifying these kinds of expressions we get by taking the square root.